The morning of June 13th, 1944, Trooper Joe Ekins sat in near total darkness, waiting. The interior of his tank smelled of oil, cordite, and the sweat of 5 men who had not properly bathed in 7 days. Through the narrow vision slit, he could see nothing but hedgerow, the endless green walls of Norman bocage that turned every field into a potential killing ground. His hands rested on the controls of a gun that shouldn't have existed. A gun the Germans didn't know about yet. A gun that, in the next few hours, would prove that Britain's most desperate gamble had worked. 7 days earlier, Ekins had rolled off a landing craft onto Gold Beach as part of the greatest amphibious invasion in history. His tank, a Sherman, the most common Allied tank of the war, looked identical to thousands of others grinding through the French countryside. But it wasn't. Where a standard Sherman mounted a 75mm gun, adequate for infantry support but nearly useless against German heavy armour, Ekins' tank carried something else entirely. A British 17-pounder anti-tank gun, one of the most powerful weapons of its kind in the world. The Germans called standard Shermans Ronsons after the cigarette lighter, because they burned so easily when hit. They had a dark joke, lights for the first time, every time. But they didn't have a name yet for what the British had created. They called it the Sherman Firefly, and Joe Ekins was about to demonstrate exactly why German tank commanders should have learned to fear it. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand what made the Firefly necessary, you must first understand the mathematics of armoured warfare in 1944. These were not abstract calculations. They were equations written in the lives of young men, computed in the seconds between when a German tank appeared and when your own tank exploded. By the summer of 1944, American industry had achieved something remarkable. The M4 Sherman rolled off production lines faster than any tank in history. Detroit, Pittsburgh, and a dozen other cities transformed themselves into the greatest military-industrial complex ever assembled. At peak production, American factories completed a new Sherman every 30 minutes. This was mass production on a scale that Germany, with its over-engineered Panthers and Tigers, could only dream of matching. But this industrial miracle came with a trade-off that would be paid in blood. The Sherman's 75mm gun could penetrate approximately 68mm of armour at 500 yards under optimal conditions. Against the German Panzer Mark IV, this was barely adequate. Against the Panther, which began appearing in significant numbers in Normandy, it was effectively useless. The Panther's frontal glacis plate was 80mm thick, but sloped at such an angle that it provided the equivalent protection of 140mm. The Tiger I's frontal armour was 100mm of vertical steel. American tank crews developed a grim saying that circulated through every armoured unit: "It takes 5 Shermans to kill a Tiger." The problem is, the Tiger always gets 4 of us first. The geometry of this imbalance was brutal. A Panther could destroy a Sherman at 1,500 yards, nearly a mile. The Sherman had to be close to within 300 yards, often less, to have any realistic chance of penetrating a Panther's side or rear armour. That meant crossing open ground while being shot at by a gun that could pierce your armour from distances where you couldn't even effectively return fire. British crews, receiving thousands of Shermans through the Lend-Lease program, faced exactly the same problem. But they also possessed something the Americans lacked: a gun capable of killing German heavy tanks at range. The Ordnance quick-firing 17-pounder was born from Britain's desperate position in 1941 and 1942. As a towed anti-tank weapon, it was a monster. The gun fired a 17-pound armour-piercing shot at nearly 3,000 feet per second, almost 1,000 feet per second faster than the Sherman's 75mm. The penetration figures were staggering by the standards of 1943, 140mm of armour at 1,000 yards. This meant it could punch through a Tiger's frontal armour at distances where the Tiger couldn't effectively return fire. Against a Panther, positioned correctly, it was even more devastating. British anti-tank crews using towed 17-pounders achieved remarkable success in North Africa and Italy, but towed guns had a fatal weakness: they couldn't manoeuvre. Once their position was identified, German tanks could suppress them with high explosive rounds or simply bypass them. What Britain needed was mobility. They needed to put the 17-pounder into a tank, but here the problems multiplied exponentially. The gun was enormous, designed to be towed by a truck, not squeezed into a tank turret. British engineers attempted to mount it in the Churchill infantry tank, but the Churchill was too slow for the mobile warfare envisioned for the invasion of France. They tried fitting it into the Cromwell cruiser tank, but the recoil forces would literally tear the turret assembly off its mounting. In late 1943, Major George Brighty of the Royal Artillery had an idea that seemed nearly impossible: mount the 17-pounder in an American Sherman. The engineering challenges were immense and immediate. The 17-pounder was nearly 3 feet longer than the Sherman's standard gun. Its recoil was so violent that mounting it in the Sherman's existing turret would require a complete redesign of the interior. The gun would have to be rotated 90 degrees and mounted on its side, which necessitated designing an entirely new recoil system from scratch. The turret basket would have to be removed to make space. The radio, normally positioned in the turret, would have to be moved to the hull, complicating communication. The loader would have to work in an impossibly cramped space, handling shells that weighed significantly more than 75mm rounds. And somehow, all of this would have to be accomplished while keeping the modifications secret from German intelligence. The solution involved a level of deception that extended to the tank's external appearance. British engineers designed the Firefly so that, from more than a few hundred yards away, it looked nearly identical to a standard Sherman. The 17-pounder's distinctively long barrel was disguised with a muzzle brake that, from a distance, made it resemble an American 76mm gun, a weapon the Americans were beginning to field, but one far less powerful than the 17-pounder. German tank commanders, scanning the battlefield through their optics, would see what appeared to be an ordinary Sherman. By the time they realized they were facing something different, it would often be too late. The first production of Fireflies emerged from British workshops in early 1944. The plan called for equipping each troop a 4-tank unit with 1 Firefly and 3 standard Shermans. This ratio was born of necessity rather than choice. Converting Shermans to Fireflies required extensive handwork. Each conversion took weeks. By the time of the Normandy invasion, only approximately 200 Fireflies had been completed. The tactical doctrine developed around this scarcity. The Firefly would hang back slightly in any engagement, using the other tanks as spotters and, frankly, as bait. When German heavy tanks revealed themselves by engaging the standard Shermans, the Firefly would strike from 800 or 1,000 yards, distances where its superior gun gave it an overwhelming advantage. Joe Ekins was 21 years old when he was assigned as gunner to a Sherman Firefly in the 1st Northamptonshire Yeomanry, part of the British 33rd Armoured Brigade. His commander, Sergeant Gordon, was a veteran who understood immediately what their tank represented. They were simultaneously the most valuable and the most hunted asset in any engagement. German doctrine, updated rapidly as reports of Fireflies filtered back from the front, was explicit: identify and destroy Fireflies first. German tank commanders learned to look for subtle differences, the slightly different profile of the gun, the way Firefly crews positioned themselves in formations, any small detail that might reveal which Sherman carried the 17-pounder. Firefly crews developed counter-tactics in response. They would remove the distinctive muzzle brake, making identification harder but sacrificing some accuracy. They positioned themselves at the rear of formations when possible. They learned to fire and immediately relocate, never staying in one position long enough for German gunners to range them effectively. Most importantly, they learned patience. A Firefly crew that revealed itself too early, before identifying all enemy armor on the battlefield, risked drawing fire from multiple German tanks simultaneously. The ideal engagement involved waiting sometimes for agonizing minutes until the perfect shot presented itself. Ekins trained obsessively with the 17-pounder during the months before the invasion. The gun was paradoxically both easier and harder to use than the 75mm. Easier because the shell's higher velocity meant less drop over distance, requiring less compensation for range. Harder because the gun's sheer size made the entire tank less stable when firing, and the faster shell gave you less time to correct if your initial aim was off. But when it worked, when the shot was clean, the results were devastating. A 17-pounder armor-piercing shot didn't just penetrate armor. Upon breakthrough, the kinetic energy converted to heat, sending fragments of superheated metal ricocheting through the target tank's interior at hypersonic speeds, killing crew members, igniting ammunition, transforming a 60-ton machine into a funeral pyre in seconds. On the 6th of June, 1944, Ekin's Firefly rolled off a landing craft onto Gold Beach. The beach was chaos incarnate, landing craft grinding onto sand, men running through surf, the distant crump of artillery, smoke obscuring everything beyond 100 yards. But the initial German resistance at Gold Beach had been lighter than at Omaha or Juneau. By nightfall, British forces had pushed several miles inland. The plan called for a rapid advance to capture the city of Caen, whose road network was essential for any Allied breakout from the beachhead. 7 days later, Caen still had not fallen. German resistance had stiffened dramatically. And on the 13th of June, the 1st Northamptonshire Yeomanry was part of a force pushing toward Villers-Bocage, a town whose crossroads would allow British forces to outflank the German defences. The morning started quietly, perhaps too quietly. British intelligence reported minimal German armour in the sector. The advance proceeded smoothly down the narrow road toward Villers-Bocage. Tanks bunched more closely than tactical doctrine recommended. But the terrain, those endless hedgerows, made dispersal difficult. Around 8:30 in the morning, the lead elements entered the town itself. Buildings showed signs of hasty German withdrawal. Equipment had been left behind. Perhaps, for once, the advance would proceed without significant resistance. Then the first Cromwell exploded. The tank simply disintegrated, its turret lifting off and crashing back down like a discarded toy. Before anyone could process what had happened, 2 more Cromwells tried to maneuver. They were destroyed before their guns could even traverse toward the threat. In less than 2 minutes, 4 British tanks had been annihilated without landing a single shot in return. The attacker, identified by survivors as a Tiger I heavy tank, then disappeared into the town's streets. What followed was every tank commander's nightmare. Radio traffic became frantic and fragmented. Units reported Tiger sightings from multiple directions. Was it one tank or several? Where was it engaging from? The neat British column, stretching back along the road from Villers-Bocage, had become a death trap. Tanks were bunched together, unable to maneuver in the narrow lanes bordered by stone walls and high hedgerows. And somewhere in that maze, a Tiger was hunting them. The Tiger's commander was SS Obersturmführer Michael Whitman, though British forces wouldn't learn his identity until much later. Whitman was already a legend on the Eastern Front, personally credited with destroying 117 Soviet tanks. He understood armoured warfare with an instinctive brilliance that most commanders never achieved. More importantly, he was aggressive to the point of recklessness, willing to drive directly into enemy formations if it gave him a tactical advantage. On the morning of June 13th, he had that advantage. The British tanks were strung out, unable to support each other, presenting their vulnerable side armour as they tried to manoeuvre in the confined space. Whitman worked his way systematically down the column. A Sherman attempted to reverse away from the fight destroyed from the rear, where even the Sherman's thin armour couldn't save it. 2 Cromwells tried a flanking manoeuvre through an orchard, both killed before they could get into firing position. A British anti-tank gun crew managed to unlimber their weapon and get into action. They fired 3 shots in rapid succession. All 3 rounds bounced harmlessly off the Tiger's frontal armour. The Tiger's return shot obliterated the gun and its crew with a single high-explosive round. In 15 minutes, Whitman destroyed 15 British tanks and 13 other vehicles, including half-tracks, transport trucks, and reconnaissance vehicles. It was one of the most devastating individual performances in the history of armoured warfare. British commanders frantically tried to reorganise, to establish some kind of coherent defence, but the psychological impact was overwhelming. Crews were abandoning tanks without even attempting to fight. Officers were ordering retreats. The carefully planned advance toward Villas Bocage had collapsed into chaos. But Wittmann made one critical miscalculation. He assumed all the British tanks were standard Shermans and Cromwell's targets his Tiger could engage with near impunity at any range. He didn't know about the Fireflies, and that ignorance was about to cost him. Joe Ekins heard the battle before he saw it. The distinctive crack of an 88mm gun, the Tiger's main weapon, echoed across the Norman countryside. Black smoke rose from multiple points along the road ahead. His radio crackled with fragmentary, sometimes panicked transmissions. All tanks, enemy heavy armor, engage at will. Tiger, grid reference. The transmission cut off abruptly. Charlie, 2, is gone, oh God. He's right on top of us. Sergeant Gordon's voice cut through the chaos in Ekin's headset, measured and deliberate. Steady on. We move forward, slowly. Stay off the main road. Their Firefly pulled off the paved surface, moving through an orchard parallel to the road where other British tanks were dying. This was standard procedure. Let the regular Shermans engage first, draw the German tanks' attention and fire, then strike from an unexpected angle with the 17-pounder. Through his periscope, Ekins could see the carnage. Tanks burning, their ammunition cooking, off in secondary explosions. Crew members scrambling for cover, some of them on fire. The organised British advance had been completely shattered in minutes, and somewhere in that chaos was a Tiger. For the next 3 hours, Ekins and his crew played a deadly game of patience and positioning. They would move to a new location, scan methodically for targets through the hedgerows, then relocate before German observers could pinpoint their position. The Tiger, or Tigers, because no one was certain how many were active in the sector, kept moving, firing, disappearing into the maze of narrow streets and high vegetation. The bocage terrain of Normandy created a nightmare environment for armoured warfare. Visibility rarely exceeded a few hundred yards. A 60-ton tank could be 50 feet away, concealed behind an earthen wall topped with ancient vegetation, and you would have no idea it was there until it fired. British tactics evolved in real time, born of desperation and survival instinct. Regular Shermans would probe forward deliberately, exposing themselves as bait. If the Tiger took the shot, Fireflies waiting in concealed positions would have perhaps 10 seconds the time it took a German crew to reload, to identify the Tiger's position, acquire the target, aim, and fire, before the German tank could either reload and engage them, or simply relocate. It was psychological warfare as much as armoured combat. Tiger crews, so accustomed to having every advantage in tank versus tank engagements, suddenly had to consider that any Sherman might be a Firefly. Every engagement carried the risk that they might be the ones outgunned. Around midday, British forces managed to stabilise a defensive perimeter. The German attacks had lost momentum. Intelligence officers, piecing together fragmentary reports and survivor testimony, concluded that the assault had most likely been conducted by a single Tiger, commanded by a highly skilled crew. After-action analysis would later identify this as Wittmann's tank, though at the time the British had no idea who they were facing. The same Tiger might still be operating in the area. And at 12:47 in the afternoon, Ekins finally got his opportunity. Movement. 11 o'clock. Range 800 yards. Sergeant Gordon's voice in the headset was quiet, almost conversational, the tone of a man who had learned not to let adrenaline affect his speech. Ekins swung the gun in the indicated direction, peering through the sight. For several seconds, he saw nothing but smoke and the irregular shadows cast by hedgerows and damaged buildings. Then there, a massive grey shape moving behind a screen of trees, perpendicular to their position. A Tiger. His heart rate accelerated, but his hands remained steady on the controls. The Tiger was moving at perhaps 10 miles per hour, apparently unaware of the Firefly's position. In perhaps 5 seconds, maybe less, it would disappear behind a stone farm building. This might be the only shot they would get. Target identified. Tiger, side aspect, moving left to right. Ekins kept his voice level, professional, exactly as he had been trained. Fire when ready. Gordon responded. Ekins drew a breath, held it. The trick with the 17-pounder was leading the target slightly less than intuition suggested. The shell's velocity was so high that overcorrection was the most common error among gunners transitioning from the 75mm. He placed the crosshairs just ahead of the Tiger's center mass, aiming for the junction between turret and hull, where the armor, though still thick, was slightly more vulnerable than the frontal glacis. Firing. The Firefly rocked backward violently from the recoil. Even with the modified recoil system, the 17-pounder's discharge was extraordinarily violent. Through the sight, fighting to reacquire the target through the smoke from his own gun, Ekins saw the armor-piercing shot cross 800 yards in, substantially less than a second. Sparks erupted from the Tiger's side armor where the shell impacted. A hit, but not penetration. The shot had struck at a slightly oblique angle, and the Tiger's side armor, though thinner than its frontal protection, was still formidable. The Tiger stopped immediately, its commander clearly aware he was under fire. The massive turret began traversing toward the Firefly's position. German crews were trained to be extraordinarily fast. Ekins knew he had perhaps 5 seconds before an 88mm round would come back at them, and at this range, even a near miss could disable his tank. "Reload! Reload!" He didn't need to shout, the loader was already slamming another 17-pound shell into the breech. The confined space of the modified turret meant every movement had to be precise. There was no room for fumbling. "Up!" the loader called out, signalling the gun was loaded and ready. Ekins didn't wait for Gordon's order. He had maintained his sight picture, kept the crosshairs on the Tiger even as it began to traverse. He fired again. This time, the result was unmistakable and catastrophic. The second shot penetrated the Tiger's side armor cleanly, and the tank didn't burn, it exploded. The 17-pounder's penetrating shot had struck something critical, most likely the ammunition storage. The turret lifted off its mounting, propelled upward by the force of the internal explosion. Flames and thick black smoke erupted from every hatch simultaneously. The most feared tank in the Wehrmacht's arsenal, destroyed in 2 shots from 800 yards by a weapon the Germans hadn't known existed 3 months earlier. Through the smoke and flames, Ekins could see small figures scrambling away from the burning wreck. The Tiger's crew, at least some of them, had survived and were attempting to escape. Standard doctrine in such situations was to fire high-explosive rounds at escaping enemy crew members. Trained tank crews were a more valuable resource than the tanks themselves. Killing them meant those men couldn't crew another tank tomorrow. But Gordon's voice came through the headset. "Hold fire. They're done." It was a decision that said something about the kind of war the British were trying to fight, even in the midst of carnage. The engagement at Villers-Bocage on June 13th ended in tactical confusion. Whitman's Tiger had withdrawn earlier after expending most of its ammunition. The tank Ekins destroyed had been from the same unit, commanded by a different officer. British forces ultimately pulled back from Villers-Bocage rather than risk additional casualties in the close terrain that so favoured defending armour. By strict military accounting, the day was a German tactical victory. They had held the ground. But something fundamental had changed in the psychological calculus of tank warfare in Normandy. Word spread rapidly through British armoured units. The Firefly worked exactly as designed. Given proper positioning, patient crews, and reasonable shooting conditions, it could destroy German heavy tanks at ranges where standard Shermans were helpless. More importantly, the engagement proved that Tigers were not invincible. They could be outmaneuvered, outweighted, and killed. For British tank crews who had spent weeks feeling outgunned and outclassed, this was a profound psychological shift. They had a weapon now that gave them a chance. German tank commanders, for their part, began treating every Sherman with a new wariness. Intelligence reports filtering back from the front warned of up-gunned American tanks capable of penetrating Tiger armor. The exact specifications were unclear. German intelligence initially thought the British might be using captured German guns, but the tactical implications were obvious. The qualitative superiority that German crews had enjoyed since 1943 was no longer absolute. Every engagement now carried the possibility that, One of those Shermans might be a Firefly, and by the time you identified which one, it might already have fired. The British pushed to increase Firefly production dramatically. The original allocation had been 1 Firefly per 4-tank troop. Now commanders were requesting 2, even 3 per troop, but production couldn't keep pace with demand. Each Firefly required weeks of hand modification work. The 17-pounder gun itself was in limited supply, with competing demands from towed anti-tank units and other applications. By the end of the war, only approximately 2,000 Fireflies would be produced, a tiny fraction of total Sherman production, which exceeded 50,000 units. This scarcity made Fireflies precious, and it made their crews targets. German tactical doctrine evolved rapidly. Orders went out to all armoured units: identify and eliminate Fireflies before engaging other targets. German tank commanders learned to scan formations for the distinctive gun profile, the slightly different exhaust signature, and the way Firefly commanders positioned their tanks. Some British crews responded by removing identifying features, including the muzzle brake, accepting reduced accuracy in exchange for survivability. Others leaned into the psychological warfare, deliberately making their Fireflies visible to draw German tanks into engagements where other British armour could exploit their distraction. Joe Ekins, for his part, continued fighting through Normandy as the Allied breakout slowly materialised. His Firefly survived 3 more significant engagements with German armour in the weeks following Villers-Bocage. In late June, his crew destroyed 2 Panzer Mark IVs in a single engagement near Caen. In mid-July, they engaged and destroyed a Panther that had been dominating a crossroads, preventing British infantry from advancing. Each engagement reinforced the same lesson. At range, with a prepared position and patient crew, the Firefly gave British tankers a decisive advantage. The 17-pounder's penetration power meant they could engage German heavy tanks before those tanks could effectively return fire. But the Firefly's success created its own problems. German crews became obsessed with identifying and destroying them. Firefly casualties began mounting as German tankers learned to recognize them more quickly. The distinctive gun barrel, even disguised, was longer than anything else on the battlefield. Experienced German commanders learned to look for tanks hanging back in formations, tanks that maneuvered differently, tanks whose crews seemed more patient about engaging. By late July, Firefly losses had reached levels that concerned British commanders. The tanks were irreplaceable in any reasonable time frame, and the crews even more so. On August 8, 1944, 2 months after the Normandy landings, British forces launched Operation Totalize, a massive armoured thrust designed to capture the town of Falaise and trap the retreating German armies in a pocket. The 1st Northamptonshire Yeomanry was advancing down Route Nationale 158 when they encountered elements of the 101st Heavy SS Tank Battalion. Michael Whitman's unit, and Michael Whitman himself was commanding a Tiger that day. What happened next has been debated by historians for decades. The exact sequence of events, the precise timing, even which Allied unit deserves credit for Whitman's death, all of these remain contested. But certain facts are not in dispute. Around 12:40 in the afternoon, 3 Tigers appeared on a ridgeline overlooking the British advance. They began engaging targets at long range with devastating accuracy. British tanks exploded, burned, scattered. For British crews, it must have felt like Villers-Bocage all over again. Tigers dominating the battlefield with seeming impunity, killing at ranges where return fire was nearly impossible. But this time, the British formation included 5 Fireflies, and one of them was commanded by Sergeant Gordon, with Joe Ekins as gunner. Through his periscope and gun sight, Ekins watched the Tigers methodically destroying his comrades' tanks. Range: approximately 1,000 yards. The Tigers were positioned hull down on the ridge, only their turrets visible above the crest, presenting the smallest possible target profile and maximizing the protection of the terrain. Under normal circumstances, under the tactical doctrine of 1943, this would have been an impossible engagement. The Tigers held every advantage position: armour, firepower, visibility. Ekins fired anyway. The first shot missed. At 1,000 yards, against a partially concealed target, even the 17-pounder's flat trajectory and high velocity couldn't guarantee a hit. The shell passed perhaps 2 feet over the Tiger's turret, close enough that the Tiger commander certainly heard and possibly felt it. The Tiger's turret began traversing toward the Firefly's position. If it acquired them, if it fired first, the Firefly's armor would provide no meaningful protection at this range. The second shot did not miss. Aiken's 17-pounder shell struck the Tiger's turret ring, the junction between the turret and the hull, one of the few vulnerable points on a Tiger's frontal aspect. The penetration was catastrophic and immediate. The Tiger's turret stopped traversing. Thick black smoke began pouring from the commander's cupola and the loader's hatch. No crew members emerged. The tank simply sat there on the ridgeline, smoke billowing, a metal coffin for the 5 men inside. The tank Joe Ekins had just destroyed was Tiger 007, commanded by SS Obersturmführer Michael Wittmann, the most successful tank ace of World War II, personally credited with destroying 138 Allied tanks and 132 anti-tank guns over 2.5 years of combat, was dead. Killed by a single, shot from a British gunner in a modified American tank at a range where Wittmann probably believed he was invulnerable. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Ekins wasn't finished. With Wittmann's Tiger destroyed, the other 2 German tanks on the ridgeline began maneuvering, trying to identify where the fatal shot had originated. Ekins fired twice more in rapid succession, his loader working frantically in the cramped turret to keep the gun fed with ammunition. Both shots found their marks. 2 more Tigers were destroyed within minutes. In a single engagement lasting less than 10 minutes, Joe Ekins had killed 3 of the most feared tanks in the Wehrmacht at ranges where those tanks' commanders believed they held an insurmountable advantage. The psychological impact of Wittmann's death rippled through German armoured units far beyond its tactical significance. Wittmann had been more than just a successful tank commander, he had been a propaganda symbol, proof of German technical and tactical superiority. His death, and the manner of it killed at long range by a tank he probably didn't recognize as a threat until it was too late, undermined fundamental assumptions about armoured warfare that had sustained German tankers through 2 years of increasingly desperate fighting. The profound irony at the heart of the Sherman Firefly's story becomes clear when you step back and examine the larger context. The Americans had designed the Sherman with a specific philosophy: adequate performance, maximized production. They explicitly chose not to pursue the kind of technical excellence that characterized German tank design. The calculation was ruthless but logical. Build 5 tanks to every one of theirs, accept higher casualties per engagement, and win through overwhelming numerical superiority. This was industrial warfare in its purest form: victory through production capacity rather than individual unit superiority. The British took America's adequate tank and transformed it into something the Germans learned to fear. By mounting a gun, the Sherman was never designed to carry a gun that barely fit in the turret, that forced crews to work in extraordinarily cramped conditions, that made the tank slightly slower and mechanically less reliable. They created one of the most effective tank destroyers of the war. The Firefly proved that the Sherman's fundamental design wasn't the fatal flaw. The gun was the problem. And with the right gun, the Sherman could kill anything on the battlefield. The Americans, ironically, resisted adopting the 17-pounder. American doctrine and institutional pride demanded American solutions to American problems. They eventually developed the 76mm gun for the Sherman, substantially better than the 75mm, but still inferior to the 17-pounder in penetration and effective range. American tank crews in Normandy, watching British Fireflies destroy Panthers and Tigers at distances where their own Shermans were helpless, begged their commanders for access to the 17-pounder. They were refused. The British would keep the Fireflies for their own units. And so American tankers continued dying in Shermans armed with 75mm guns, closing to suicidal ranges because their weapons couldn't penetrate at distance, while just a few hundred yards away, British tankers in mechanically identical Shermans killed German heavy tanks from 1,000 yards. The shared sacrifice of the Allied cause had its limits, it seemed, when it came to the distribution of the war's most effective weapons. The combat record of the Sherman Firefly, compiled from after-action reports and unit histories, was extraordinary by any measure. Though Fireflies made up only approximately 10% of British Sherman tanks in northwest Europe, they accounted for roughly 50% of all German heavy tanks destroyed by British armoured forces from June 1944 through May 1945. A single Firefly in a tank troop could dominate an entire engagement. German commanders learned to prioritize destroying Fireflies above all other targets, but identifying them in the chaos and smoke of combat proved nearly impossible. Often, the first indication that you were facing a Firefly was the 17-pounder shell penetrating your armor. The tactical revolution the Firefly represented went beyond simple firepower. It changed the fundamental psychology of tank versus tank combat in ways that are difficult to quantify, but were immediately apparent to the men doing the fighting. German tank crews, so long confident in their qualitative superiority, now had to approach every engagement with caution. That Sherman at 800 yards, was it a standard 75mm, essentially harmless at that range, or was it a Firefly, capable of killing your Tiger with a single shot? The uncertainty itself was a weapon. It slowed German responses, made commanders more cautious, created hesitation where previously there had been aggressive confidence. British crews, conversely, found their tactical options expanded dramatically. With a Firefly in the troop, they could engage German heavy tanks on something approaching equal terms. The psychological burden of fighting a Tiger, that sense of facing something technically superior, nearly invulnerable, lifted when you knew your formation included a gun that could kill it at range. Morale improvements are difficult to measure, but multiple British accounts from Normandy reference the profound psychological relief of having Fireflies in their units. Joe Ekins survived the war. His final tally: 7 German tanks destroyed, including 3 Tigers, one of them commanded by Michael Wittmann, the most feared tank ace of World War II. He was awarded the military medal for his actions, though the full details of his engagement with Wittmann weren't widely known until decades later. After the war, Ekins rarely spoke about his experiences. He worked as a lorry driver, lived quietly in Rushden, Northamptonshire. When researchers and historians eventually tracked him down in the 1990s and early 2000s, seeking details about the engagement that killed Wittmann, Ekins was characteristically modest. He described it as simply doing his job. The shot that killed Wittmann was, from his perspective, not fundamentally different from any other shot he'd taken during the war. You identified a target, you aimed, you fired. The fact that the target happened to be crewed by Germany's most successful tank commander was, in Ekins' view, largely irrelevant. The Sherman Firefly itself was phased out with remarkable speed after the war ended. New tank designs, incorporating lessons learned from 5 years of armoured warfare, made it obsolete almost immediately. Most Fireflies were scrapped within 2 years of VE Day. The guns were removed, often returned to towed anti-tank configurations, or simply destroyed. Today, only a handful of complete, operational Fireflies survive in museums worldwide. They sit behind velvet ropes, painted in period-accurate camouflage patterns, their long 17-pounder guns pointing at nothing, silent testimony to a brief moment when desperate ingenuity created something that changed the mathematics of armoured warfare. The technical specifications that made the Firefly effective, the 17-pounder's muzzle velocity, its penetration figures, the modifications required to mount it in the Sherman's turret, these are preserved in engineering documents and historical analyses. But the human experience of crewing a Firefly is harder to preserve. The cramped interior, where the loader had perhaps 18 inches of space to maneuver shells weighing over 30 pounds. The deafening noise when the gun fired, in the confined space. The knowledge that you were simultaneously your unit's most valuable asset and its most hunted target. The psychological weight of knowing that German doctrine prioritized killing you above all other threats. Veterans' accounts from Firefly crews consistently reference the claustrophobia of the modified turret. The radio, moved to the hull to make space for the gun, meant the commander had to relay all communications through the hull crew, adding crucial seconds to response times. The gun's size meant that in some positions, it physically couldn't traverse fully without the tank itself repositioning. These were not minor inconveniences, they were potentially fatal limitations that crews had to work around constantly. The fact that Fireflies achieved the combat record they did, despite these limitations, speaks to the desperation that drove their creation and the skill of the men who crewed them. In 2001, an 82-year-old man named Joe Ekins stood in a field near Saintonge, France, looking at a memorial to the tank battles of Operation Totalize. He had returned to Normandy for the first time since the war, brought by a British documentary team researching the death of Michael Whitman. A historian asked him what he remembered most about his time as a Firefly gunner. Ekins thought for a long moment, looking across fields that had been battlefields 57 years earlier, then said something that captured the entire story in a single observation. "The sound?" he said. The 17-pounder made a different sound than the 75mm. Sharper, louder, echoed differently. When you heard that sound on the battlefield, you knew someone had a chance. He paused, still looking across those peaceful French fields where young men had died in burning tanks. The Germans had the best tanks, the best armor, the best guns in the world. They had every advantage you could want in armored warfare, but they didn't account for us taking their advantage away. Not with something better. We never had something better than a Tiger. We just made something that was good enough to kill it. And that turned out to be all we needed. The Sherman was never the best tank of World War II. By any objective technical measure, it was inferior to the Panther, inferior to the Tiger, arguably inferior even to the later models of the Panzer Mark IV. But the Firefly proved something more important than technical superiority. It proved that ingenuity, born of desperation, combined with skilled crews and sound tactics, could overcome a significant technological disadvantage. That a tank derided by its enemies as a Ronson could become something German tank commanders learned to fear. Michael Whitman destroyed 138 Allied tanks in his career spanning 2.5 years of combat. He survived engagements on the Eastern Front that killed thousands of other German tankers. He became the face of German armoured excellence, proof that superior training and superior equipment could overcome numerical disadvantages. He was killed by a single shot from a tank he almost certainly believed was inferior to his own, fired by a 21-year-old British gunner who viewed it as simply another shot in another engagement. That single fact, that one moment on a ridgeline in Normandy on August 8, 1944, encapsulates the entire story of the Sherman Firefly. The Germans didn't just lose to superior numbers. They didn't just lose to Allied industrial capacity. They lost, in part, because the British took America's most common tank and made it lethal in ways the Germans never anticipated. They lost because ingenuity can be as powerful as engineering excellence. They lost because at some point, having the technical advantage matters less than having a weapon that's good enough, used by crews who know how to employ it. The Germans laughed at Shermans. They called them Ronsons. They killed them by the hundreds. And then the Fireflies started shooting back, and the laughter stopped. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The night is absolute. No moon cuts through the tropical clouds over Mindoro Island this December evening in 1944. Inside the cockpit of his Northrop P-61 Black Widow, Major Carroll Smith cannot see his own instrument panel without the faint red glow of his cockpit lights. Outside, the darkness is so complete that the horizon has ceased to exist. There is only the void, and somewhere in that void, a Japanese bomber. Behind Smith, separated by a thin bulkhead, Lieutenant Philip Porter hunches over a glowing cathode ray screen. His eyes strain against the green phosphorescence as he watches a single bright blip crawl across the display. 4 miles away, 3.5. The blip represents a Mitsubishi G4M bomber, what the Americans call a Betty, carrying a bomb load toward the American airfield at San Jose. The Japanese crew has no idea they are being tracked. They have no idea that for the past 6 minutes, they have been hunted by something they cannot see, cannot hear, and have no means to detect. Porter's voice crackles through the intercom. Contact holding steady. 3 miles, 11 o'clock low. Smith banks the massive twin-engine fighter, feeling the aircraft respond with surprising grace despite its 29,000-pound weight. The P-61 is larger than some medium bombers, yet it turns with the agility of a much smaller aircraft. He eases the throttles forward slightly, closing the distance. This is the new warfare. This is the invisible hunt that has transformed the night sky from a refuge into an execution chamber. And for the Japanese aircrew flying through the darkness ahead, their war is about to end in a way they cannot possibly comprehend. For 3 years, since the attack on Pearl Harbor, Japanese bomber crews had owned the night. They had terrorized Allied positions across the Pacific with impunity, dropping their payloads under cover of absolute darkness and vanishing before anyone could respond. American forces had coined dozens of nicknames for these nocturnal raiders. Washing Machine, Charlie, Bedcheck Charlie, Louis the Louse, each name reflecting both the frequency of the attacks and the helplessness of those on the receiving end. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The psychological toll of these night raids far exceeded their material damage. A single Japanese bomber could keep an entire airfield awake for hours, disrupting rest, fraying nerves, and creating a pervasive sense of vulnerability. Soldiers would hear the distinctive, unsynchronized drone of Japanese engines in the darkness and know that somewhere above them, invisible and unreachable, an aircraft was circling, searching for targets. Anti-aircraft guns would fire blindly into the night. Searchlights would sweep the sky, rarely catching more than a glimpse of a shadow. And then bombs would fall, seemingly at random, and the bomber would disappear back into the protective darkness. American attempts at night interception had been largely futile. The Douglas P-70 night fighters, hastily converted A-20 attack bombers, with primitive radar installations, were painfully inadequate for the task. Their British-designed SCR-540 airborne intercept radar had a maximum effective range of barely 2 miles, and only under ideal conditions. The radar operator sat cramped in the aircraft's nose, staring at a small circular scope that displayed contacts as faint green blips that often disappeared in ground clutter. Even when the radar did detect an enemy aircraft, the P-70 was too slow and too sluggish to catch most Japanese bombers. It took these converted bombers nearly 45 minutes just to climb to 20,000 feet, and their service ceiling topped out below 28,000 feet. Japanese crews quickly learned these limitations and adjusted their tactics accordingly. But in June of 1944, a new predator arrived in the Pacific theater. The Northrop P-61 Black Widow represented a fundamental shift in the balance of nocturnal warfare. Unlike every other night fighter that had come before it, the P-61 was not a converted bomber or a day fighter fitted with crude radar equipment. It was the first American aircraft designed from the ground up for a single purpose: to find and destroy enemy aircraft in total darkness. Everything about the Black Widow was purpose-built for night operations. Its twin-boom configuration, with 2 Pratt & Whitney R2800 double-wasp engines producing 2,000 horsepower each, provided the power and stability needed for extended patrols in darkness. The aircraft's broad, high aspect ratio wings generated tremendous lift, allowing it to carry its heavy load of fuel, ammunition, and electronics while maintaining excellent maneuverability. Test pilots reported that despite its bomber-like dimensions, a 66-foot wingspan, and a length of nearly 50 feet, the P-61 could execute maneuvers that would be aggressive even for a conventional, single-engine fighter. The only prohibited flight maneuvers were outside loops, sustained inverted flight, and deliberate spins. The crew of 3 worked in an unusual configuration that reflected the aircraft's specialized mission. The pilot sat in the front of the central nacelle, with a clear view through a multi-panel greenhouse canopy. Behind, and slightly above him, sat the gunner, who controlled the dorsal turret when it was installed. Further back, In the rear of the nacelle, the radar operator sat at his station, separated from the rest of the crew by equipment racks and bulkheads. This physical isolation was intentional. The radar operator needed to focus entirely on his scope, free from outside visual distractions. His world was the glowing green display of the SCR-720 radar, and his ability to interpret that display could mean the difference between a successful intercept and another Japanese bomber escaping into the night. The armament was devastating. 4 20mm Hispano M2 autocannons were mounted in the lower fuselage, firing forward with a combined rate of fire that could reach 2,400 rounds per minute. Each high-explosive shell weighed approximately 4 ounces and could tear through aluminum airframe structures like paper. The dorsal turret, when fitted, carried 4 50-caliber M2 Browning machine guns that could be aimed and fired by either the gunner or the radar operator, providing defensive coverage for the hemisphere above and behind the aircraft. Some P-61 variants also carried underwing bombs or additional fuel tanks for extended-range missions. But the real weapon, the element that transformed the P-61 from merely another aircraft into a revolutionary instrument of war, was the radar system mounted in the aircraft's nose. The SCR-720 Airborne Intercept Radar represented a quantum leap forward in detection technology. Unlike earlier systems that operated on longer wavelengths and suffered from significant ground clutter and limited range, the SCR-720 used microwave frequencies that provided unprecedented clarity and detection distance. The system consisted of a 30-inch parabolic dish antenna that rotated continuously inside the nose radome, sweeping the airspace ahead of the aircraft in a constant search pattern. The radar could detect aircraft-sized targets at ranges exceeding 5 miles under good conditions, and often achieved detection ranges of 3 to 4 miles even in poor weather. The radar's display, mounted at the operator's station, showed contacts as bright green blips on a circular scope. The operator could determine not only the target's bearing and range, but also its relative altitude by observing the shape and intensity of the return signal. An experienced radar operator could distinguish between single aircraft and formations, could estimate the target's speed based on how quickly the range closed, and could even make educated guesses about the type of aircraft based on the radar return's characteristics. A large bomber produced a stronger, more consistent return than a small fighter. An aircraft flying in formation created overlapping returns that appeared as an elongated or irregular blip. The entire radar system weighed over 400 pounds, not including the cables and mounting equipment required to integrate it into the aircraft. This was a significant weight penalty, but the capability it provided was worth every pound. For the first time in the Pacific War, American night fighters could detect enemy aircraft at ranges that allowed for a proper intercept setup. No longer did crews have to rely on visual sightings or wait for searchlights to illuminate their targets. The radar operator could vector the pilot onto an intercept course while the target was still miles away, positioning the P-61 in the enemy's blind spot before closing for the kill. To maximize the aircraft's effectiveness in darkness, Northrop and the Army Air Forces developed a specialized paint scheme. Initial production P-61s were delivered in standard olive drab and neutral gray camouflage, but combat experience quickly revealed that this was inadequate for night operations. Enemy searchlights could still pick out the aircraft against the night sky. In February of 1944, the Army approved a new finish. Jet black, applied directly to bare metal rather than over existing paint. The result was an aircraft that absorbed light rather than reflecting it. When a jet black P-61 passed through a searchlight beam, it appeared as little more than a momentary shadow, often dismissed as an optical illusion by ground observers. Japanese searchlight operators sometimes illuminated a Black Widow without, realizing they had done so, allowing the aircraft to continue its approach unmolested. The development of the P-61 had been driven by urgent necessity. In October of 1940, as the Battle of Britain raged and German bombers pounded London by night, the United States Army Air Corps recognized that America would need a capable night fighter if it entered the war. British successes with radar-equipped night fighters like the Bristol Beaufighter and de Havilland Mosquito demonstrated the viability of the concept, but the United States had no equivalent capability. On January 30th, 1941, nearly a year before Pearl Harbor, the Army awarded Northrop Aircraft a contract for 2 prototype XP-61 aircraft. The design process moved with remarkable speed considering the technological challenges involved. Jack Northrop, the company's founder and chief designer, assembled a team of engineers to create an aircraft around the new SCR-720 radar system, which itself was still under development. The requirements were demanding. The aircraft needed to carry a 3-man crew, heavy armament, sufficient fuel for patrols lasting several hours, and all the electronic equipment necessary for night operations. It needed to be fast enough to catch enemy bombers, but stable enough to serve as a steady gun platform. It needed to be maneuverable despite its size, and it needed to be forgiving enough that pilots could fly it safely in the total darkness of a moonless night. The first XP-61 prototype flew on May 26, 1942. Northrop test pilot Vance Breeze reported that the aircraft handled well despite its unconventional configuration. The twin-boom layout provided excellent stability, and the large empennage surfaces gave the pilot positive control even at low speeds. The aircraft's wide-track tricycle landing gear made ground handling straightforward, an important consideration given that most operations would occur in darkness. But moving from prototype to production proved more challenging than anticipated. The SCR-720 radar system experienced development delays. The dorsal turret, which used the same General Electric design, being produced for the Boeing B-29 Superfortress, was in short supply, and the B-29 program had priority. Early production P-61A models were delivered without the turret, and some were delivered without fully functional radar systems. Flight testing revealed that when the turret was installed and traversed from side to side, it created buffeting that affected the aircraft's handling. Solving this problem required structural modifications that further delayed production. The first P-61s did not reach combat units until March of 1944, when the 422nd Night Fighter Squadron arrived in England. By that time, the war had been raging for more than 4 years, and the need for effective night fighters was acute. In the Pacific, Japanese night raiders continued to harass American positions with relative impunity. The primitive P-70 night fighters and radarless P-38 Lightnings pressed into night fighter service achieved only sporadic successes. Ground-based searchlight cooperation where day fighters would attempt to intercept bombers illuminated by searchlights was dangerous for the friendly fighters and rarely effective. The 6th Night Fighter Squadron, based at Guadalcanal in the Solomon Islands, received the first P-61s to reach the Pacific Theater in early June of 1944. The aircraft arrived in crates and had to be assembled by squadron maintenance personnel. The mechanics worked around the clock, fitting wings to fuselages, installing engines and propellers, connecting electrical systems, and calibrating the delicate radar equipment. As the P-61s took shape on the flight line, pilots who had been flying the inadequate P-70 finally saw a glimmer of hope that they might actually be able to stop the nightly Japanese raids. The first operational P-61 mission in the Pacific occurred on June 25, 1944. The squadron launched several aircraft on patrol, but no enemy contacts were made. The missions continued nightly. Pilots and radar operators practiced their intercept procedures, learning to work together as cohesive teams. The pilot had to trust his radar operator completely, making heading and altitude changes based solely on the operator's verbal directions. The radar operator had to interpret the green blips on his scope accurately, filtering out ground returns and weather returns to identify genuine aircraft contacts. On the night of June 30th, 1944, 5 days after the first operational mission, Second Lieutenant Dale Haberman and his radar operator, Flight Officer Raymond Mooney, were on patrol over Saipan when ground control radioed that they had detected an intruder inbound toward the island. Haberman, whose aircraft was named Moon Happy, acknowledged the call and adjusted his heading to position for an intercept. Mooney hunched over his radar scope, searching for the contact among the ground clutter returns from the volcanic island below. Then he had it. A single bright blip, ranging 4 miles, heading directly toward Saipan. Contact. He called over the intercom. 12 o'clock, slightly high. Haberman eased his throttles forward and began climbing, following Mooney's directions. The range decreased steadily. 3 miles, 2 miles. As they closed, Mooney's experienced eye detected something unusual about the radar return. It was fluctuating slightly, showing 2 overlapping blips rather than a single clean return. "There's 2 of them," he reported. "Looks like a fighter tucked in close to a bomber." This was a common Japanese tactic. The bomber would serve as a navigation aid for the fighter, whose pilot would stay in close formation until they approached the target area. The fighter could then attack any American night fighters that attempted to intercept the bomber. It was an effective countermeasure against the limited capabilities of the P-70 and Searchlight cooperation methods. But the Japanese tactics had been developed against an enemy that couldn't see in the dark. Haberman and Mooney had radar. They could track both aircraft simultaneously and choose their attack angle accordingly. Haberman brought the P-61 in from below and behind the formation, positioning himself in the bomber's blind spot. At 1 mile, he throttled back slightly to avoid overshooting. At half a mile, he could see them. Dark shapes against the slightly less dark sky, the bomber's distinctive twin-engine silhouette, unmistakable even in the gloom. At 300 yards, Haberman pressed the firing button. The 4 20mm cannons erupted in a stuttering roar. High-explosive shells tore into the bomber's fuselage and wing roots. In just 3 seconds, Haberman fired 60 rounds. The bomber didn't burn immediately, it simply began to come apart. One wing folded back. The aircraft rolled inverted and fell, trailing debris and flame, until it impacted the ocean below. The escort fighter, alerted by the muzzle flashes from Haberman's cannons, immediately broke formation and came around hard, searching for the attacker. Mooney, tracking the fighter on radar, shouted a warning, "He's on our tail!" Haberman didn't hesitate. He threw the P-61 into a steep dive, dropping the port wing and heading for the deck at full throttle, kicking the rudder pedals to throw off the enemy pilot's aim. A burst of fire from the Japanese fighter's guns passed wide. By the time the enemy pilot could adjust his aim, the P-61 had disappeared into the darkness below, its jet-black finish rendering it invisible against the dark ocean. The Japanese fighter pilot, now alone and disoriented in unfamiliar airspace with no navigation aid, apparently decided discretion was the wiser course. He turned for home. Haberman and Mooney circled back to their patrol station, their hearts pounding but their aircraft undamaged. It was the first confirmed kill for a P-61 in the Pacific Theater. More importantly, it was a proof of concept. The Black Widow could find enemy aircraft in total darkness, close to killing range without being detected, and destroy targets with overwhelming firepower before the enemy even knew they were under attack. Word of the successful intercept spread quickly through the night fighter squadrons. Pilots who had spent months flying fruitless patrols in inadequate aircraft now had a weapon that could actually accomplish the mission. Ground crews worked with renewed enthusiasm, knowing their efforts were supporting aircraft that could make a real difference. Intelligence officers began to notice a change in Japanese night raiding patterns. The bombers were coming less frequently, and when they did come, they seemed more cautious, more prone to abort their missions at the first sign of trouble. The Japanese, for their part, were slow to understand what had changed. Their intelligence services knew the Americans had introduced a new night fighter, but the full capabilities of the P-61's radar system were not immediately apparent. Japanese aviators who survived encounters with Black Widows reported attacks that came without warning, from aircraft they never saw. Some reported hearing a distinctive whistling sound, the airflow over the P-61's broad wings seconds before cannon fire tore through their aircraft. Others reported nothing at all, just the sudden catastrophic failure of their aircraft structure as shells found their mark. As summer turned to autumn in 1944, more P-61 squadrons became operational across the Pacific. The 419th Night Fighter Squadron, operating from Guadalcanal and later from bases in the Philippines, began scoring regular kills against Japanese night raiders. The 421st Night Fighter Squadron, assigned to 5th Air Force in New Guinea and the Southwest Pacific, flew both night interception missions and nocturnal ground attack sorties, using their radar to navigate to targets in complete darkness. The 418th Night Fighter Squadron, which would eventually produce the highest-scoring night fighter ace in the Army Air Forces, arrived in the theater in late 1944 and immediately began aggressive patrols over the Philippines. The 418th Squadron's commanding officer, Major Carroll Smith, was an experienced pilot who had previously flown P-38 Lightnings. He approached night fighting with a methodical professionalism that served him well in the demanding environment of nocturnal combat. Smith understood that successful night fighting required perfect coordination between pilot and radar operator, and he spent considerable time training with his regular radar operator, Lieutenant Philip Porter, until they could work together almost instinctively. On December 29, 1944, Smith and Porter were on patrol over Mindoro when they received a vector from ground control toward a contact heading for the American airfield at San Jose. Porter picked up the target on radar at 5 miles and began calling heading corrections to Smith. The intercept proceeded smoothly, the range decreasing steadily as Smith positioned the P-61 behind and slightly below the target. At 1 mile, Smith could see the target visually. A twin-engine bomber, probably another Betty, flying straight and level with no indication its crew suspected they were being stalked. Smith closed to 400 yards, centered the target in his gun sight, and fired. The bomber exploded spectacularly, its fuel tanks detonating in a ball of orange flame that briefly illuminated the night sky before falling away into darkness. Smith and Porter continued their patrol. Less than an hour later, ground control vectored them toward another contact. Again, Porter acquired the target on radar. Again, Smith positioned for the attack. Again, the 20mm cannons spoke, and another Japanese bomber fell burning into the Philippine jungle. They scored a third kill that night, and then a fourth. 4 enemy aircraft destroyed in a single mission, a remarkable achievement that demonstrated both the P-61's capabilities and the skill of an experienced crew. The kills were officially shared between Smith and Porter, following Army Air Force's policy that gave equal credit to both members of a night fighter crew. After all, the pilot could not see the target without the radar operator's guidance, and the radar operator's detection was meaningless without the pilot's flying skill. By the end of December 1944, the 418th Night Fighter Squadron had destroyed 12 Japanese aircraft in just 13 nights of operations. Other squadrons were achieving similar success rates. The balance of nocturnal warfare had shifted decisively. Where once Japanese bomber crews had flown with confidence, knowing that darkness protected them, they now flew in fear, knowing that somewhere in that darkness an invisible predator might be tracking them, preparing to strike without warning. Japanese intelligence officers interviewed surviving air crews and pieced together a picture of what was happening. The Americans had deployed aircraft with detection equipment that could track Japanese planes through complete darkness at ranges of several miles. These aircraft were fast enough to intercept bombers, maneuverable enough to position for attacks, and armed heavily enough to destroy targets with short bursts of fire. Countermeasures were urgently needed. The Japanese response to the P-61 threat evolved through the final months of 1944 and into 1945. But every countermeasure proved inadequate against the fundamental technological advantage the Americans now possessed. Japanese bomber crews attempted to fly higher, pushing their aircraft to altitudes above 30,000 feet in the hope of exceeding the American night fighters' operational ceiling. The P-61s simply climbed to meet them. The Black Widow's service ceiling exceeded 40,000 feet, well beyond what most Japanese bombers could achieve, especially when carrying full bomb loads. Some Japanese units attempted to use chaff-thin strips of aluminum foil cut to specific lengths that would create false returns on radar screens. This technique, which the Germans called Doppel and the British called window, had proven effective against longer wavelength radar systems. Japanese engineers calculated the proper dimensions for chaff that would theoretically confuse the American radar, and bomber crews began carrying bundles of the metallic strips to scatter during their approach runs. But the SCR-720 radar operated on microwave frequencies that were far less susceptible to chaff interference than the older systems. The chaff created brief spurts of clutter on the radar operator's scope, but an experienced operator could distinguish between the diffuse, stationary returns from chaff and the solid, moving return from an actual aircraft. The countermeasure had minimal effect. Japanese night fighter units attempted to provide escort for bombing missions, but this proved difficult to coordinate. Japanese aircraft lacked the sophisticated radar and radio equipment that would have allowed them to effectively protect bomber formations in darkness. Fighter pilots had to maintain visual contact with the bombers they were escorting, which meant flying in close formation throughout the entire mission. This made both the fighter and bomber more vulnerable, as they presented a larger, combined radar signature. Additionally, Japanese fighters of this period were optimized for daylight combat and maneuverability rather than for the steady, stable flight patterns required for night operations. Many Japanese fighter pilots lacked the instrument flying skills necessary to operate safely in total darkness, and nighttime formation flying accidents were not uncommon. By early 1945, Japanese night bombing tactics had undergone a fundamental shift, where once Japanese bomber crews had approached their targets directly, flying steady courses that allowed their bombardiers to aim accurately, they now employed evasive maneuvers throughout their entire approach. Bombers would zigzag, making random altitude and heading changes to complicate any potential intercept. Some crews, upon detecting any indication of American night fighters in the area, whether from radio chatter, searchlight activity, or reports from other aircraft, would immediately jettison their bombs into the ocean and turn for home rather than risk engagement. Intelligence reports from the period reveal the psychological impact this had on Japanese air units. Bomber crews that had once operated with confidence now flew their missions in a state of constant anxiety. Every sound, every shadow, every instrument fluctuation could signal the presence of an American night fighter positioning for the kill. The knowledge that they could be tracked without knowing it, that an enemy aircraft might be closing on them at that very moment, created a level of stress that went beyond normal combat tension. It was the helplessness that wore on them most severely, the understanding that if a Black Widow had found them, their first indication would likely be the impact of 20mm shells tearing through their aircraft. Some Japanese bomber units simply stopped flying night missions altogether. The attrition rate had become unsustainable, and the psychological toll on surviving crews was degrading unit effectiveness even when aircraft were available. Other units shifted to different tactics entirely, attempting low-level approach flights below radar coverage or timing their attacks for periods of poor weather when they hoped the American radar would be less effective. Neither approach proved consistently successful. The P-61's radar could detect aircraft at very low altitudes if the geometry was favorable, and weather that degraded radar performance also made bombing more difficult for the Japanese crews. The human cost of these operations, on both sides, deserves examination. For American night fighter crews, the work was demanding in ways that differed from daylight combat. The physical act of flying in total darkness, often for 4 or 5 hours at a stretch, required intense concentration. Pilots had to maintain precise control of their aircraft while navigating by instruments alone, with no external visual references. The temptation to trust one's vestibular sense, the inner ear's perception of motion over the instruments, could be deadly. Spatial disorientation in darkness killed pilots just as surely as enemy fire, and the transition from instrument flight to visual attack required split-second decision-making in conditions that strained human perception to its limits. For radar operators, the work involved long periods of eye-straining attention to the glowing scope, searching for the faint blips that might indicate an enemy aircraft among the ground clutter and weather returns. A momentary lapse in concentration, a brief distraction, could mean missing a contact entirely. The responsibility was immense. The pilot was flying blind, trusting the radar operator's interpretations completely. An error in reading the scope, a mistake in calculating relative positions, could send the P-61 away from the target rather than toward it. Or worse, could vector the aircraft into terrain or into a mid-air collision. The gunners, when carried as part of a three-man crew, had perhaps the most frustrating role. They sat for hours in darkness, cramped in their stations, with nothing to do unless the aircraft came under attack from behind, a relatively rare occurrence, given the P-61's speed advantage over most Japanese aircraft. Many P-61 units operated with two-man crews, eliminating the gunner position to save weight and allow for additional fuel capacity. The dorsal turret was often removed entirely or locked in a forward-facing position, giving the pilot additional firepower but eliminating the defensive capability. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The maintenance demands of the P-61 were substantial. The aircraft was mechanically complex, with its twin engines, intricate electrical systems, and temperamental radar requiring constant attention from ground crews. The radar system, in particular, was a maintenance nightmare. It consisted of hundreds of vacuum tubes, any one of which could fail and render the entire system inoperative. The rotating antenna mechanism in the nose required careful alignment and lubrication. The waveguide plumbing that carried the radar signals from the transmitter to the antenna had to be kept free of moisture and debris. A single, loose connection, a corroded contact, or a cracked insulator could degrade the radar's performance or cause complete failure. Ground crews worked in difficult conditions to keep the Black Widows operational. In the Pacific Theater, heat and humidity were constant enemies of electronic equipment. Moisture condensation inside radar components caused short circuits and corrosion. Tropical insects built nests in electrical junction boxes and chewed through wire insulation. Dust and sand, kicked up by propeller wash on unpaved airstrips, infiltrated every opening and abraded moving parts. Maintenance personnel developed ingenious improvised solutions to these problems, fashioning moisture-absorbing packets from local materials, fabricating replacement parts on the spot when supply lines couldn't deliver the needed components, and conducting field repairs that would have horrified factory engineers but kept the aircraft flying. The logistics of supporting night fighter operations in the far-flung Pacific Islands added another layer of complexity. Spare parts had to be shipped thousands of miles, often passing through multiple supply depots before reaching frontline squadrons. Specialized test equipment for the radar systems was in perpetually short supply. Technical manuals were sometimes incomplete or outdated, having been printed before late production modifications were implemented. Maintenance officers had to balance the need to keep aircraft mission-ready against the limited availability of replacement components, sometimes cannibalizing one aircraft to keep others flying. Despite these challenges, the P-61 units maintained impressive readiness rates. Squadron maintenance officers took pride in their ability to launch missions every night, weather permitting. The mechanics, armorers, and electronics technicians, who worked through the day to prepare aircraft for the night's operations, understood that their efforts directly translated into saved American lives and destroyed enemy aircraft. When a P-61 returned from a successful mission, when the crew climbed down from their aircraft and confirmed another kill, the ground crews felt a justified sense of accomplishment. The tactical employment of the P-61 evolved as commanders and crews gained experience with the aircraft's capabilities and limitations. Early missions followed a relatively simple pattern. Ground-based radar would detect an incoming raid, night fighters would be scrambled or vectored from patrol stations, and the radar operators would search for the contacts, while pilots positioned for intercepts. This required close coordination between ground controllers and airborne crews, with radio communication being the critical link. But radio discipline in 1944 was often poor, especially in the chaotic environment of night operations. Multiple aircraft might be operating in the same area, all trying to communicate with the same ground controller. Radio frequencies would become cluttered with overlapping transmissions, making it difficult to understand individual messages. Some pilots and radar operators developed their own shorthand communication systems, using brevity codes to minimize radio traffic. Others simply maintained radio silence, except for essential transmissions, relying on their radar operators to find targets independently. As the campaign progressed, some units began experimenting with more aggressive tactics. Rather than waiting for ground controllers to detect raids and vector fighters toward them, P-61 crews would patrol known approach routes to Japanese airfields, loitering in areas where enemy aircraft were likely to pass. This put the night fighters in position to intercept bombers as they formed up after takeoff or as they returned from missions when the Japanese crews were most vulnerable and least expecting attack. The 418th Night Fighter Squadron, operating from bases in the Philippines, became particularly adept at this offensive patrolling. Major Carroll Smith, who would finish the war as the Army Air Force's highest-scoring night fighter ace with 7 confirmed kills, advocated for aggressive forward patrols that took the fight to the enemy rather than waiting to react to Japanese initiatives. Smith described the experience of night fighting in his post-war writings, noting that downing airplanes in total darkness was rather a thrilling experience that required absolute trust between pilot and radar operator. Smith's crew scored their most remarkable success on the night of December 29th and 30th, 1944, when they destroyed 4 Japanese aircraft in a single mission. The squadron's records for that period show an intense pace of operations. During a 13-night span in late December, the 418th destroyed 12 enemy aircraft, a remarkable achievement that demonstrated both the effectiveness of the P-61 platform and the skill of experienced crews operating at peak efficiency. Not all missions ended successfully. The nature of night operations meant that many patrols resulted in no contact with enemy aircraft. Weather frequently interfered with both Japanese bombing attempts and American interception efforts. Thunderstorms, common in the tropical Pacific, created massive radar returns that obscured genuine aircraft contacts. Heavy rain degraded radio communication and made instrument flying even more challenging. Low clouds obscured visual references, making the final attack phase, when the pilot needed to see the target to identify it as hostile before firing, difficult or impossible. There were also combat losses. Japanese gunners, though unable to see their attackers in darkness, sometimes scored hits with defensive fire during the brief moments when the P-61's cannon muzzle flashes revealed its position. Anti-aircraft fire from both Japanese positions and, tragically, from American forces who failed to properly identify friendly aircraft claimed several Black Widows. Mechanical failures during night operations over water often proved fatal, as crews had limited options for emergency landings in darkness. Navigation errors, spatial disorientation, and mid-air collisions all took their toll. Yet, despite these losses, the overall effectiveness of the P-61 in the night fighter role was undeniable. By early 1945, Japanese night bombing raids against American positions had declined dramatically. Where once Japanese bomber formations had operated nightly over Allied-held islands and airfields, now only occasional single aircraft attempted nocturnal missions, and even these were often aborted. At the first indication of American night fighter activity, the psychological transformation this represented cannot be overstated. For 3 years, from Pearl Harbor through mid-1944, darkness had belonged to the Japanese. Their bomber crews had used the night as both weapon and shield, striking at will and vanishing before effective countermeasures could be deployed. American soldiers, sailors, and airmen had endured countless sleepless nights, listening to the drone of enemy engines overhead, knowing that bombs might fall at any moment and that they were essentially powerless to prevent it. The frustration and fear this generated had real operational consequences, degrading combat effectiveness through exhaustion and stress. The arrival of the P-61 reversed this dynamic completely. Within 6 months of the Black Widow's combat debut in the Pacific, the night had become hostile territory for Japanese aviation. Where once they had flown with confidence, Japanese bomber crews now approached their targets with dread, knowing that at any moment an invisible hunter might be tracking them through the darkness. The advantage had shifted so completely that by early 1945, some Japanese commanders questioned whether night operations were worth the losses being sustained. The technological disparity was stark. Japanese attempts to develop equivalent radar-equipped night fighters produced limited results. The Nakajima J-1N1 Irving, a twin-engine fighter that had been adapted for night operations, carried primitive radar equipment and achieved some success in defensive operations around Japanese home islands. But the Japanese radar systems lagged years behind American and British technology. Detection ranges were shorter, resolution was poorer, and reliability was problematic. Japanese radar operators had to work with equipment that provided only the most basic target information. Nothing like the clear, actionable picture that the SCR-720 radar presented to American operators. Moreover, Japanese production capacity was strained to the breaking point by early 1945. While American factories were producing thousands of aircraft per month, Japanese production facilities struggled under the weight of strategic bombing, resource shortages, and infrastructure damage. The specialized components required for radar systems, vacuum tubes, precision electronics, rare metals, were increasingly difficult to obtain. Even when Japanese engineers designed capable systems, actually building them in sufficient quantities to make a difference was beyond the nation's industrial capacity at that stage of the war. The human factor compounded these material disadvantages. By 1945, Japan was suffering from a critical shortage of experienced aircrew. The massive attrition of the previous 3 years had consumed the pre-war cadre of skilled pilots and navigators. Replacement training programs, hampered by fuel shortages and the need to disperse training facilities to avoid American bombing, produced aviators with minimal flight time and inadequate preparation for the demands of combat. Night flying, which required advanced instrument skills and hundreds of hours of experience to perform safely, was particularly affected. Many Japanese replacement pilots lacked the fundamental proficiency needed to operate safely in darkness, even without the added stress of combat. American night fighter crews, by contrast, received extensive training before deployment. The Army Air Forces had established dedicated night fighter training facilities, where pilots and radar operators spent months learning their craft. Pilots flew hundreds of hours of instruments-only training, developing the skills needed to control their aircraft with no external visual references. Radar operators practiced on ground-based simulators before progressing to actual airborne radar systems, learning to interpret the dokias, scope displays and vector pilots onto intercept courses. Two-man crews trained together, developing the communication patterns and mutual trust essential for effective night fighting. This training investment paid dividends in combat. Experienced P-61 crews achieved remarkable success rates. The best crews, like Major Smith and Lieutenant Porter of the 418th Night Fighter Squadron, developed an almost intuitive coordination. Porter could anticipate Smith's flying characteristics and adjust his radar intercept vectors accordingly. Smith trusted Porter's guidance completely, making heading and altitude changes based purely on Porter's verbal instructions without needing to understand the radar picture himself. This level of teamwork took time to develop, but once achieved, it made the crew far more effective than the sum of its individual parts. The comparison with Japanese capabilities became even more stark when examining the broader operational context. American night fighter squadrons operated as part of an integrated air defense system that included ground-based radar networks, radio communication systems, and centralized control centers that could track multiple contacts simultaneously and coordinate multiple fighter responses. When a Japanese raid was detected, ground controllers could vector the nearest available P-61 toward the threat, while simultaneously alerting anti-aircraft batteries and activating searchlight crews. The night fighter crew received continuous updates on the tactical situation, allowing them to adjust their intercept plan based on the latest information. Japanese bomber crews, in contrast, often operated with minimal support. Communication with their home bases was limited to basic navigation updates and mission orders. Japanese ground-based radar coverage was spotty, and what systems existed were generally less sophisticated than American equivalents. Japanese bomber formations often flew without any real-time information about American defensive dispositions, essentially navigating blind into hostile airspace and hoping to reach their targets before being intercepted. When they encountered P-61s, they were often tactically isolated, unable to receive assistance or even warning from other Japanese forces in the area. The material and training advantages the Americans possessed were further amplified by industrial capacity. By 1945, the United States was producing vast quantities of war materiel at a pace Japan simply could not match. When a P-61 was lost to combat or an accident, the squadron could expect a replacement aircraft to arrive within weeks, sometimes days. When electronic components failed, spare parts were available from well-stocked supply depots. When ammunition was expended, fresh loads arrived on regular supply flights. The American war machine, operating at full capacity, could sustain losses and maintain operational tempo indefinitely. Japan, meanwhile, was being strangled by the American submarine campaign and strategic bombing offensive. Raw materials that would have gone into aircraft production were sitting on the bottom of the Pacific Ocean or couldn't be extracted from mines that had been bombed. Factories that could have produced radar components or aircraft engines had been destroyed or were operating at a fraction of their capacity. Fuel shortages meant that even when aircraft were available, flying them was problematic. Training flights were curtailed to conserve fuel, which meant replacement pilots arrived at combat units with even less preparation than before. These converging pressures created a death spiral for Japanese aviation. Inexperienced pilots flew obsolescent aircraft with inadequate equipment against an enemy that enjoyed massive material superiority and complete technological dominance in key areas like radar. The losses mounted steadily, consuming both aircraft and the irreplaceable experienced personnel needed to train new crews. By the spring of 1945, many Japanese air units existed more on paper than in reality, with listed strengths that bore little resemblance to their actual operational capability. The strategic implications of American night fighter dominance extended beyond the direct impact of aircraft destroyed. The psychological effect on Japanese bomber crews degraded the effectiveness of those units, even when they managed to avoid interception. Crews that flew in constant fear of invisible hunters made mistakes, dropped bombs inaccurately, and were more likely to abort missions prematurely. The knowledge that darkness no longer provided protection undermined the confidence that had characterized Japanese night operations in earlier years of the war. Moreover, the suppression of Japanese night bombing allowed American forces to operate more efficiently. Airfields and supply depots that had previously required extensive anti-aircraft protection and frequent repairs could now function with fewer defensive resources. Ships unloading cargo in forward harbors no longer needed to suspend operations every night when Japanese bombers approached. Rest and recovery for combat units improved when soldiers could actually sleep through the night rather than spending hours in shelters waiting for air raids to conclude. These may seem like minor advantages, but cumulatively they represented a significant operational benefit that flowed from the P-61's dominance of the night sky. The Black Widow's success in the Pacific theater was mirrored in other operational areas, though with different tactical emphases. In the European theater, P-61 squadrons arrived in March of 1944 and were immediately thrown into combat against German Von flying bombs. These primitive cruise missiles, launched by the hundreds against England in retaliation for the D-Day invasion, were fast and small, making them difficult targets even for day fighters. At night, they were nearly impossible to intercept without radar guidance. The 422nd Night Fighter Squadron, the first P-61 unit to arrive in England, scored its first kill on July 15, 1944, when Lieutenant Hermann Ernst used his Black Widow to destroy a Von over the English Channel. The Von presented unique challenges for night fighter crews. The flying bomb's pulse jet engine created a distinctive radar signature, but the weapon's small size and high speed over 400 miles per hour meant that interception windows were brief. Additionally, destroying a Von at close range was dangerous. The 1,000-pound warhead could detonate and damage the attacking fighter. Ernst and other P-61 pilots developed tactics for engaging V-1s that involved closing to within a few hundred yards, achieving a precise firing solution, and breaking away immediately after firing to avoid the blast. The 20mm cannons were ideal for this mission, as they could destroy the flying bomb's control surfaces or detonate its warhead from a safe distance. Over the following weeks, P-61 crews destroyed dozens of V-1s, helping to blunt the German offensive and demonstrating the aircraft's versatility. In the China-Burma-India theatre, P-61 squadrons faced different challenges. The vast distances involved meant that night fighters often operated far from their home bases, patrolling enormous areas with minimal support. The 427th Night Fighter Squadron, responsible for protecting Allied positions in China, regularly conducted patrols that covered hundreds of miles of airspace. Japanese bomber crews operating in this theatre learned to respect the P-61's capabilities, often avoiding night missions entirely when they knew American night fighters were active in the area. The Mediterranean theatre saw limited P-61 operations, primarily because British night fighter squadrons equipped with Mosquitoes were already providing effective coverage. Some American night fighter units in Italy and southern France transitioned from Beaufighters to P-61s in late 1944, but by that point, German night bombing in the region had largely ceased due to fuel shortages and the general collapse of Luftwaffe offensive capabilities. Across all theatres, the P-61 compiled a respectable combat record. Official statistics credit Black Widow crews with 127 confirmed aerial victories, plus 18 Vone flying bombs destroyed. These numbers are modest compared to day fighter totals, but they must be understood in context. Night fighting was inherently more difficult than day combat. Contact rates were lower because enemy aircraft were harder to find in darkness. Many night fighter patrols resulted in no contact with enemy aircraft whatsoever. When contacts were made and intercepts achieved, the attacks were usually decisive. The element of surprise that radar provided meant that Black Widow crews rarely faced return fire until after they had already damaged or destroyed their targets. The kill-to-sortie ratio for experienced P-61 crews was actually quite impressive. Units like the 418th Night Fighter Squadron, with skilled crews and aggressive tactics, achieved success rates that compared favorably with day fighter units. The limiting factor was not the aircraft's capability or the crew's skill, but simply the decreasing number of Japanese aircraft available to engage. By early 1945, Japanese aviation had been so thoroughly depleted that finding targets became the primary challenge for American night fighters. The final chapter of the P-61's combat service unfolded in the skies over Japan itself, as American forces closed in on the home islands in the summer of 1945. By this point, the strategic situation had become desperate for Japan. The combined fleet lay shattered at the bottom of the Pacific. Japan's industrial cities were being systematically destroyed by massive B-29 superfortress raids. The Soviet Union had entered the war in the east, and in the night skies, American radar-equipped fighters patrolled with impunity, making even darkness an unreliable refuge. On the night of August 14, 1945, as Japan's government debated the terms of surrender, Lieutenant Lee Kendall and radar operator Lieutenant John Shearer lifted off from their base on Ia Shima in their P-61, named Lady in the Dark. The official cessation of hostilities had been announced, but not all Japanese forces had received or accepted the surrender order. Some pilots were still flying, either unaware that the war had ended or unwilling to accept that reality. Kendall and Shearer's radar picked up a contact, a lone Nakajima Ki-43 Hayabusa, called Oscar by Allied intelligence. The Japanese fighter was heading toward Allied positions, possibly on a kamikaze mission, possibly simply because its pilot hadn't heard the surrender broadcast. Kendall positioned Lady in the Dark behind the Oscar and began closing for an intercept. The Japanese pilot spotted the massive black shape materializing from the darkness behind him. In that moment, he must have understood that he was facing one of the invisible hunters that had terrorized Japanese aviators for the past year. He reacted with panic rather than tactical precision. The Oscar dove toward the ocean, the pilot attempting desperate evasive maneuvers at wave-top altitude. He pulled the aircraft through violent turns, trying to shake the pursuer that stayed locked behind him with uncanny precision. Kendall followed every maneuver, his radar operator calling out Oscar's position continuously, allowing Kendall to anticipate each turn. The Japanese pilot pushed his aircraft beyond its limits. The Oscar's airframe, stressed by the violent maneuvering at low altitude, couldn't withstand the punishment. The aircraft struck the water and exploded in a spray of debris and flame. Kendall and Shearer had achieved a kill without firing a shot. The mere presence of the P-61, the knowledge that it was there and that escape was impossible, had caused the enemy pilot to destroy himself. It was, in a sense, the ultimate expression of the psychological dominance the Black Widow had achieved. Japanese pilots feared it so much that they would rather risk death through extreme maneuvering than face its guns. The following night, August 15th, Kendall and Shearer flew again. Once more, they encountered a Japanese aircraft, this time a Nakajima Ki-44 Shoki, called Tojo by the Allies. Again, wild maneuvering followed as the P-61 closed in. The two aircraft twisted through the darkness, Kendall using his radar guidance to stay on the Tojo's tail. The Japanese fighter broke contact briefly, disappearing into clouds, but Shearer's radar found it again. Finally, the Tojo disappeared for good. The next day, ground forces found the wrecked aircraft. The pilot had apparently lost control during the violent evasive maneuvers and crashed. These were, unofficially, the last aerial victories of World War II in the Pacific. The official last kills went to a B-32 Dominator bomber crew who shot down two A-6M0 fighters on August 18th during a photo reconnaissance mission over Japan. But Kendall and Shearer's encounters on August 14th and 15th represented something more symbolically significant. They demonstrated that even after Japan's surrender, even after the Emperor's broadcast announcing the end of hostilities, Japanese pilots still feared the Black Widow enough to choose death over engagement. This fear, cultivated over 12 months of one-sided nocturnal warfare, represented a complete reversal of the psychological balance that had existed at the beginning of 1944. Japanese aviation, which had begun the war with confidence and technical competence, ended it in a state of near paralysis when facing certain American capabilities. The P-61 was perhaps the most dramatic example of this technological and psychological superiority, but it was far from the only one. The broader story of the Pacific War's final year is one of escalating American dominance across every dimension of warfare. Industrial production, technological innovation, tactical flexibility, strategic coordination in all these areas, the United States had achieved advantages that Japan simply could not counter. The P-61's success in night fighting was emblematic of this larger pattern. American engineers had identified a problem, the vulnerability of forces to night attack, and had developed a comprehensive solution that integrated advanced technology, effective training, and sound tactical doctrine. The result was a weapons system that not only solved the immediate problem, but actually reversed it, turning the night sky from an enemy advantage into an American one. For the Japanese aviators who survived their encounters with Black Widows, the experience left lasting impressions. Post-war interviews with former Japanese pilots reveal consistent themes: the terror of being tracked by an enemy they couldn't see, the helplessness of flying through darkness, knowing that at any moment cannon shells might tear through their aircraft, and the gradual erosion of morale as successful night missions became increasingly rare. Some Japanese pilots described the experience of night flying in 1945 as resembling a hunt, but with themselves as the prey and the darkness offering no protection. The material record supports these subjective impressions. Japanese night bombing missions declined dramatically in frequency and effectiveness from mid-1944 onward. Units that had previously conducted nightly raids against American positions began flying only sporadically, and when they did fly, they often aborted missions if any indication of American night fighter activity was detected. The sortie rates tell the story clearly. Japanese night bombing in the final year of the war represented a fraction of what it had been in 1943, and the tonnage of bombs actually delivered to targets fell even more precipitously. The American night fighter squadrons, meanwhile, faced a different problem: not enough targets. By spring of 1945, P-61 crews were flying long patrols that resulted in no contact with enemy aircraft. Some squadrons went weeks without achieving a single intercept. This was, in a sense, the ultimate measure of their success. They had so thoroughly suppressed Japanese night operations that there was nothing left to intercept. Squadron commanders began assigning alternative missions: night interdiction against ground targets, weather reconnaissance flights, and even limited ground attack missions using bombs or rockets carried under the P-61's wings. The 418th Night Fighter Squadron, based on Okinawa by July of 1945, began conducting strikes against targets on the Japanese home islands, on Hainan Island, and along the China coast. These missions represented a significant departure from the aircraft's original purpose, but they kept crews proficient and contributed to the broader campaign against Japanese infrastructure. The powerful radar that made the P-61 such an effective night fighter also made it useful for navigation in bad weather and for locating ground targets at night. The heavy cannon armament that could destroy bombers could also devastate locomotives, supply trucks, and small vessels. Major Carroll Smith, who finished the war with 7 confirmed night kills and the distinction of being the Army Air Force's highest-scoring night fighter ace, participated in many of these ground attack missions. He described the transition from pure night interception to multi-role operations as necessary but somewhat frustrating. The P-61 had been designed for a specific mission, and while it could perform other roles adequately, its true capabilities shone in aircraft versus aircraft combat. That there were so few Japanese aircraft left to fight by mid-1945 was a testament to the success of the overall American campaign, but it also meant that the Black Widow's most valuable attribute, its radar-guided night interception capability, was underutilized in the war's final months. The atomic bombings of Hiroshima and Nagasaki in early August 1945, followed by the Soviet invasion of Manchuria, brought the war to a close before the planned invasion of Japan could be executed. The P-61 squadrons, which had been preparing to support the invasion by providing night air defense over the landing beaches and establishing air superiority during darkness hours, instead found themselves transitioning to occupation duties. Black Widows flew patrols over Japan in the weeks immediately following the surrender, ensuring that any remaining Japanese aircraft attempting unauthorized flights were intercepted. Some P-61s participated in the massive aerial demonstration over Tokyo Bay during the surrender ceremony aboard USS Missouri on September 2, 1945, a reminder to all present of the overwhelming air power that had helped bring Japan to its knees. The post-war period brought significant changes for the night fighter community. The Army Air Forces, facing budget pressures and the need to demobilize millions of personnel, began rapidly reducing its force structure. Many P-61 squadrons were inactivated within months of the war's end. The 418th Night Fighter Squadron remained in Japan as part of the occupation force until June of 1946, then was inactivated. The 6th Night Fighter Squadron, the first unit to score a P-61 kill in the Pacific, was inactivated in February of 1947. Of the 14 night fighter squadrons that had operated Black Widows during the war, only a handful remained active by 1948. The P-61 itself continued in service for several more years, but in diminishing numbers and increasingly specialized roles. The Army Air Forces, which became the independent United States Air Force in September of 1947, struggled to develop a viable jet-powered night fighter. Early jet aircraft lacked the endurance and stability needed for long night patrols, and integrating radar systems into the new jets proved technically challenging. As a result, the P-61, redesignated F-61 after the new fighter designation system, was adopted in 1948, remained in frontline service longer than originally anticipated. Some F-61s were converted for specialized roles that took advantage of the aircraft's unique characteristics. The 15A Reporter, developed from the P-61 airframe, served as a photo reconnaissance platform with cameras installed in a modified nose section. These aircraft participated in mapping projects and conducted reconnaissance flights well into the 1950s. Other F-61s were modified for weather reconnaissance, participating in the National Thunderstorm Project between 1946 and 1949. This research program, sponsored by the U-S Weather Bureau and the National Advisory Committee for Aeronautics, used the aircraft's radar and sturdy airframe to penetrate thunderstorms and collect data on their internal structure. The knowledge gained from these flights contributed significantly to understanding severe weather phenomena and improving aviation safety. The last operational F-61s were retired from active Air Force service in 1952, nearly a decade after the first P-61 prototypes flew. By then, jet-powered night fighters like the Lockheed F-94 Starfire and Northrop F-89 Scorpion had entered service, offering performance that the propeller-driven Black Widow could not match. Yet those who had flown the P-61 in combat remembered it fondly. Pilot after pilot, in post-war interviews and memoirs, described the aircraft as forgiving, capable, and effective. The nickname Black Widow had been chosen for its predatory connotations, and veterans felt it was apt the aircraft had indeed been a deadly hunter in the darkness. The technological legacy of the P-61 extended far beyond the aircraft itself. The experience gained in operating radar-equipped night fighters informed the development of subsequent generations of all-weather interceptors. The crew coordination techniques developed by P-61 pilots and radar operators became standard practice in later two-seat fighters. The integration of radar, navigation systems, and weapons in a single platform pioneered concepts that would be refined and expanded in future aircraft. The F-89 Scorpion, which replaced the F-61 in Air Force service, was essentially a jet-powered evolution of the same design philosophy, a large, twin-engine aircraft with a multi-man crew, heavy armament, and sophisticated radar optimized for finding and destroying targets in darkness and poor weather. The strategic lessons of the P-61's combat employment also proved enduring. The aircraft demonstrated that technological superiority in specific mission areas could yield disproportionate operational advantages. The P-61 represented less than 1% of American fighter production during World War II. Only 706 aircraft were built, compared to tens of thousands of P-38s, P-47s, and P-51s. Yet, in the specific domain of night fighting, the Black Widow achieved dominance that affected the broader campaign far beyond what its small numbers might suggest. By suppressing Japanese night operations, it allowed American forces to operate more efficiently, reduced casualties from night bombing, and imposed psychological costs on enemy aviators that degraded their effectiveness even when Black Widows weren't directly involved. This principle that focused investment in specialized capabilities could produce outsized returns would influence American military procurement for decades. The lesson was that while mass production of general-purpose platforms remained important, there was also value in developing smaller numbers of highly specialized systems optimized for specific mission sets. The P-61 proved that such systems, properly employed, could dominate their particular niche so thoroughly that enemy forces would effectively cede that domain rather than accept the losses required to contest it. For the Japanese aviators and commanders who experienced the P-61's dominance firsthand, the lessons were more painful. The aircraft represented yet another example of how American technological and industrial superiority had overwhelmed Japanese forces in the war's latter stages. Japanese military planners had understood intellectually that the United States possessed greater industrial capacity, but the lived experience of facing weapons systems like the P-61 brought that disparity home in visceral ways. Night, which had been an ally, had become an enemy. Darkness, which had protected Japanese bombers, now concealed American hunters. The reversal was complete and absolute. The human cost of this technological warfare deserves final consideration. The 127 Japanese aircraft confirmed destroyed by P-61, crews represented, at minimum, several hundred Japanese airmen killed. Most Japanese bombers carried crews of 5 to 7 men. Fighters typically had a single pilot, but some twin-engine types like the Irving had crews of 2 or 3. When a P-61's cannons found their mark and a Japanese aircraft fell burning from the night sky, human beings died in terror and agony. The American crews who pulled the triggers were professionals doing their duty, but they were also taking lives, and that reality should not be minimized even as we examine the tactical and strategic dimensions of their success. The American casualties from P-61 operations were relatively light compared to daylight fighter units, but they were not zero. Several Black Widows were lost to enemy action, mechanical failure, and operational accidents. Crews who went down over water at night had minimal survival prospects. The darkness that made the P-61 such an effective hunter also made rescue operations nearly impossible. Some crews simply disappeared, their aircraft and fate never definitively determined. Others died in crashes on landing approaches, victims of the demanding nature of night flying in heavy aircraft with limited visibility. The ground crews, too, paid a price, though theirs was measured in exhaustion and stress rather than casualties. Maintenance personnel worked brutal hours to keep the aircraft mission ready, often laboring through the day to prepare aircraft for the night's operations, and then working through the night to service aircraft as they returned from missions. Armourers loaded thousands of rounds of 20mm ammunition and 50 caliber belts. Electronics technicians troubleshot temperamental radar systems. Engine mechanics performed the constant maintenance required to keep the powerful R2800 engines running reliably. Their work was essential, but often overlooked in the narrative of combat operations. The final accounting of the P-61's contribution to victory must acknowledge both its achievements and its limitations. The aircraft was highly effective in its intended role, but its late arrival meant it saw only a year of combat. Production numbers were limited compared to other fighters, constraining its overall impact, and by the time Black Widows achieved dominance in the night sky, Japan's defeat was already inevitable for reasons that had little to do with night fighting. The submarine blockade, the strategic bombing campaign, the island-hopping advance across the Pacific. These were the campaigns that actually defeated Japan, not the nocturnal duels between P-61s and Japanese bombers. Yet within its specific domain, the P-61's impact was profound. It transformed night warfare from a Japanese advantage to an American one. It protected Allied forces from night attack during crucial periods of the campaign. It demonstrated the effectiveness of radar-equipped night fighters and pioneered concepts that would shape air combat for generations. And it inflicted upon Japanese aviation a psychological defeat that was, in some ways, as significant as the material losses it caused. The central irony of the P-61's story lies in how completely it reversed the equation of nocturnal warfare. For 3 years, from December 1941 through mid-1944, darkness had been Japan's ally. Japanese bomber crews had used the night as cover, striking at will and vanishing before effective countermeasures could be deployed. American forces had endured countless sleepless nights, listening to the drone of enemy engines overhead, knowing they were vulnerable and largely powerless to respond. The psychological toll of this asymmetry was significant, degrading morale and combat effectiveness. The P-61, with its radar eye and cannon fangs, inverted this relationship. Within months of the Black Widow's arrival, darkness had become Japanese aviation's enemy. The very element that had protected them now concealed American hunters, whose radar could track them through absolute blackness. Japanese bomber crews went from confident attackers to frightened prey, flying their missions in terror, knowing that invisible death might be positioning behind them at any moment. The psychological balance had reversed completely. This transformation occurred because American engineers and military planners had correctly identified night fighting as a technical problem amenable to technical solutions. They developed the radar technology, integrated it into a suitable airframe, created effective training programs for crews, and deployed the resulting system in sufficient numbers to make a difference. The Japanese, lacking equivalent technology and facing resource constraints that prevented them from developing it, could not counter this capability. They tried various tactics flying higher, using chaff, providing fighter escort, but none proved effective against the fundamental advantage that radar provided. The lesson, ultimately, is about the importance of technological adaptation in warfare. The side that can identify emerging threats, develop countermeasures, and deploy them effectively gains advantages that can reshape entire dimensions of combat. The P-61 was not the war's most glamorous fighter, nor its most numerous, nor its highest scoring. But it was superbly suited to its specific mission, and in that mission, it achieved a dominance so complete that the enemy essentially conceded the field, rather than continue accepting the losses required to contest it. For the men who flew the Black Widow in combat, pilots like Carroll Smith and Dale Haberman, radar operators like Philip Porter and Raymond Mooney, the aircraft represented the cutting edge of military technology applied to the ancient problem of combat. They were pioneers of a new form of warfare, using electronic eyes to see through darkness and precisely delivering overwhelming firepower against enemies who could neither see them nor hide from them. Their experiences flying long patrols through tropical nights, stalking targets on glowing radar scopes, and engaging in split-second combat in absolute darkness tested the limits of human skill and courage. When the last operational F-61 was retired in 1952, an era ended. The propeller-driven night fighter gave way to jets, and the technology that had seemed so revolutionary in 1944 was superseded by systems that were faster, longer-ranged, and more capable. But the fundamental lesson remained. In warfare, the side that can see when the enemy cannot, that can strike when the enemy cannot respond, possesses an advantage that transcends simple numerical superiority. The Black Widow flew for only 8 years, fought for only 1, and served in numbers that barely registered as a rounding error in the massive production totals of World War II. Yet its impact was real and significant. It protected American forces during a critical period. It suppressed enemy night operations. It demonstrated the viability of radar-guided interception. And it left Japanese aviators with a legacy of fear that lasted beyond the war itself. In the end, the story of the P-61 is the story of how technology transformed warfare's oldest dimension, darkness from an impenetrable cloak into a transparent medium through which trained eyes could see and skilled hands could kill. It is a story of American innovation meeting Japanese desperation, of technical superiority, overwhelming tactical courage, and of how the night sky itself became a battlefield where invisible hunters stalked terrified prey. The Japanese pilots who survived their encounters with Black Widows carried those memories for the rest of their lives. In post-war interviews, decades after the events, they still spoke with something approaching awe about the aircraft that could find them in total darkness, track them through evasive maneuvers, and destroy them without warning. For them, the P-61 represented a fundamental shift in the nature of air combat, a harbinger of a future where technology would matter more than courage or skill. They were right. The future of air combat did belong to radar-equipped aircraft, to beyond visual range engagements, to battles fought by pilots who never saw their enemies with their own eyes. The P-61 was an early step on that path, a bridge between the romantic era of dogfighting and the cold technological warfare that would characterize modern air combat. But in 1944 and 45, in the night skies over the Pacific, none of that mattered to the crews flying the missions. For them, it was simpler. There was a job to do. Protect American forces from enemy night attack. There was a tool to do it, the P-61 Black Widow. And there was an enemy who, for 3 years, had owned the night. By the time the war ended, the night belonged to America. The Japanese had learned, at terrible cost, that darkness was no longer their ally. The invisible hunters had won. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.